So mu is our mean, our average. The deviation of some data point x for some x in the data set is just calculated by x minus mu. So this is something that can be positive or negative. You have to make sure we get the correct order there. So that's our deviation. It's just how far are we from the average. And then the population variance. When I say population variance, this is one of those few times where we actually care that I'm talking about the population and not just a sample. So the population variance is denoted by, this is the Greek letter lowercase sigma. So this is sigma.
Is the sigma squared, like, is the value squared, or is the symbol sigma squared?
Yes, I know exactly what you mean. We're going to get a value, and we're going to say sigma squared equals that value, because what we really care about is the value of sigma itself. So we calculate the population variance, we call it sigma squared. Okay. So this is the sum of all of our deviations squared over n, and n is the size of the population. So we sum those up, we divide by n, that's the size of our population. And so this is our population variance. Sigma itself, which is going to be the square root of this, is the population standard deviation. And standard deviation is our important key thing that plays into these. So we're going to start with an example. Let's start with this data set of 13 numbers. So we're going to assume that this is our whole population. And I have to say it's our whole population because the formulas I gave you are for a whole population. Our population has these measurements. So our average, our mean, here is mu equals 223.07. And what we want to do is we want to figure out our population variance and standard deviation. If we go ahead and calculate our deviations, we have 128 minus mu, negative 95.0769. 219 minus mu, it's 16.6211. So I'm just taking each of these and we're going ahead and calculating each number. I squared them because I was like trying to skip a step since we sum up the squares and not just the straight up deviations, but I didn't write the in-between steps for the other ones, so 9039.6169. So I'll just have to give you the squared values because that's what I got. And then so on. I only did the first few. So we calculate the deviations. I did the deviations squared here, so it's slightly different, but I was trying to save myself some effort. So if we add up all of these, so the sum of each of these ends up being 221,266.70. That means that sigma squared, our population variance then, is this number divided by 13, which is the number of things in our population. So that gives us sigma squared equal to 17,020.5160913. And the square root gives us 130.4627, which again is our population standard deviation.